What's up? How's it going today? It's Rob. I'm back. I have been laboring over this episode for a long time, and I've been wringing my hands at how to do it and should I do it. And I've decided yes. So, this is probably going to be, for me, the hardest episode I've ever shot. Um, I'm a detail guy, and my tendency is to get down into the details. And in this episode, I'm really going to have to fight that tendency. The goal for this episode is to uh, talk about how to connect and then configure a, the basic connections for an ODIN intercom. The ODIN has a number of ways to connect to it, and I'm going to try and give you a overarching, holistic view of the ways to connect and set up connections into the ODIN. We're going to do these things: connect 3 KP panels, one via legacy connection, one via RVON, and one via OMNEO. Then we're going to connect a Dante AVIO made by Audinate to provide a program input from analog audio. Then we're going to connect a Dante Beltpack, one single Beltpack. This one's made by Studio Technologies, and it's going to use Dante in and out of the intercom for comms. And then finally, we're going to connect a ROAMEO wireless Beltpack and the associated access point. We're going to go through the physical wiring of these things, and then we're going to get into the right way to download and install all of the software components that you will need throughout this process. Yeah, you may think you don't need help downloading and installing software, but I got to tell you, in preparation for this video, I realized how easy RTS is making it these days and how I wish I'd known, and I wouldn't have struggled for years, or maybe I would have, but they've made it easy and you no longer need to struggle to install all of the software components that are needed to make the whole architecture work. All right. And then we're going to get into AZEdit, the portion that's needed to connect panels, and ultimately IPEdit, where we will point the devices at each other and instruct them as to where to get their instructions. And finally, we'll look into Dante controller, because some of the items that we talked about are not an RTS connection at all. They're just Dante. So let's get started. Okay, here's a look at the gear that we're going to be using in this demonstration. I gathered this gear and I have tried to default it. I've tried to make all the IP addresses be dynamic and take all of the jim jam out of these devices that would be misleading. Truth is that these devices have been used before. They are not in a truly defaulted state. So hopefully there isn't anything in them that's going to be confusing, but you may find a different experience when you wake your stuff up from default. So at the bottom, we have the ODIN Intercom Brain. This one is 112 ports. Yours will be licensed as you purchased it. Then we have an old KP panel. This is going to be our legacy connection, and we'll talk about what that means. The next panel up is a modern panel available for legacy connection. It can be done as RVON. It can be done as OMNEO. And this one is currently loaded with a firmware that allows us to connect via RVON. And then the top panel is a 4016. The model numbers kind of don't matter in between the two, but this one is loaded with a firmware for OMNEO, and so that will be our OMNEO connection. Then I think the order is that we will then connect program audio and use that in however it would be needed in the intercom. We will do a Dante Beltpack. Like I said, this one's made by Studio Technologies, and it is power over Ethernet. And then it's probably, we'll see if it makes the cut of this video. There may be some mentions, but it may ultimately be its own video. But we will connect a ROAMEO access point and a ROAMEO Beltpack. All right. So the first thing I'm going to do is snap some labels on these things so that we can refer to them moving forward by an example of their use, not just KP12, 3016, and 4016, because I don't know, I just work better with names than model numbers. And you see back there sitting in the back, the switch. This is a very IP intensive project, and we are going to be doing a lot of computer networking, and so that is kind of signified by the switch. All right, okay. So the first thing we're going to do when connecting key panels is address this idea of the legacy connector. The legacy connector is a class of connectors that are from yesteryear. They're connectors that were used from RTS in the past. One thing that's huge about using or making a product that is going to be at a high level for a very long time, like the RTS intercoms, is backwards compatibility. The ODIN will connect to any KP that the RTS has ever made. It's amazing. You wouldn't want to invest in a large capital investment and then have it become end of life. So the legacy connector is has been many things. It has been DB9s, it has been RJ11s, it is now available on the back of the ODIN in an RJ45. But on the KP12 that we're using, I think it's a middle-aged device and is probably pretty representative of what most people will see if they have a KP12, a KP32, some KP4s, or the Zeus economy line of panels. But it's this RJ12 connector, and of course it won't focus. But this thing has 6 positions and 6 connectors. It's an, quote, oversized phone jack, if you will. Let's see if we can make this thing focus. No. Anyways, this is not an RJ45 network cable, like we'll be doing most of these connections with, okay? It's an RJ12. The connectors are available on the aisle at Home Depot. RJ12, 6 position, 6 conductor. And you probably most easily can connect it with this flat 6 conductor ribbon cable. Pinouts are in the manuals, but we do need to very highly specify that this legacy connector is different, okay? All right. Let's get started wiring with the legacy connector. Okay, so we've got our stack of gear turned around here, and here on the ODIN there are 16 ports that can be used for the legacy connection. Like I said, this is an RJ45 in this iteration of the hardware, but in this iteration, this frame connector is an RJ12. So this RJ45 will not fit, okay? So we're using this frame connector on RJ12, and we're going to put it here into port 1. And in that, we have connected this KP via the legacy connector. Like I say, the ODIN has 16 opportunities for this, and it is pretty much hardware limited to that aspect. All right. Okay, so moving on to connecting the other KPs. There's a lot of networking jacks over here, and one of them says RVON, control, and then OMNEO primary and backup. We're actually going to connect all 3 of these jacks. We're just going to use a primary here it's available for a secondary Dante network, but we're going to connect all 3 of these networking jacks, and we're going to just plug them into this dumb switch, okay? Well, Rob, why are there so many connections on the back if we're just going to plug them all in the exact same network? I mean, you're not wrong, RTS is a very, very, very high level product that's capable of things, putting itself in very complicated situations, and they've given complicated users the ability to connect to different physical networks here. Thank you for that. However, at this level, we're going to be putting them all into the same subnet. We're going to put them all on the same switch. And let's start connecting our other KPs. Ooh, you can't see this. So this 3016 has a different set of connectors than the 4016. This frame connector is actually a legacy connector. As I told you, RTS products are always striving for backwards compatibility, and you absolutely could connect this frame to this frame connector, and we would be connected. This isn't how we're going to do it today, but I just do want to point out that the all KPs have the legacy connector. And as they've moved forward, the RJ45 connector has made its way onto the KPs and onto the frame, and this out-of-the-box networking cable will allow for that connection. All right, but what we're going to do today instead is we're going to use this OMNEO network connection. And even though it's labeled OMNEO, we're going to be using it for RVON for this connection, and we're going to put it onto the same switch. And again, we're going to do the same thing for our OMNEO connections on our OMNEO connected panel, all right, into the same switch. And because OMNEO is Dante, and we're going to take our Dante connector and we're going to put it onto the same network and the same switch. And the same thing with our Beltpack. And the same thing with our access point. Rob, this is really easy. We're just plugging them all into the same network. Yep, this is the easy part of it. Okay, so I have now fully wired this lab with network connections to the frame's different ports, to all of the devices, and I've done one legacy connection here. And that literally is logically how it's going to work. I'm going to do a little bit of housekeeping here so that I have some more room on this switch and I can actually connect my AZEdit computer to it, because your configuration computer will be running software AZEdit, IPEdit, Dante config controller, and we need to be able to be on the same wired network with those items. So going to do some rearranging, but this logically is exactly how everything is connected. So I'm going to do some housekeeping, some cleanup, some powering of these devices, and we're going to see you again on the computer.
Okay, so we've made it to the fun part of the demonstration, the software and then configuration side. I know you guys really enjoyed the wiring side. I did power everything, and the lab is really messy now because power supplies and everything. But all the hardware is over there sitting and connected. So this is the important part of how to successfully prepare yourself to build your IP intercom with one fell swoop. We're going to use this piece of software here, the RTS software suite, and it's not just AZEdit and it's not just IPEdit. There's some things to it. So we're going to click download right here, and it's going to start downloading. I'm going to cancel this download because I've already got it installed, or I've already got it downloaded. So here in downloads, you can see the zipped up folder. I have already expanded that, and I'm going to double click in here. Now, you could, if you wanted to, but please don't, just jump right here into the packages and see the different pieces of software. That's what I think I've always done. But RTS is handling this better now than maybe it used to. So I want you to use this link or this program here called Setup. And look at this. It says, do you want to install these things? Here's what I think that you should install if you are on an Odin and want to make this easy. We're going to install Atom or AZEdit 5.5 for Atom or Odin. You could use AZEdit for OMS, Odin Main Station. We're going to install IPEdit. This is the current version. We're going to install the USB drivers. Why not? There is no maybe there is. I don't remember. There is a USB connector on the front for Zeus 3 and Cronus at least, and it is available to be your connection style for AZEdit. I got to tell you, if you get into comms and you have a fully loaded computer, that fully loaded computer needs to include that USB driver, so just go ahead and do it. We're going to install the OMNEO firmware upload tool. We're going, okay, so this option is grayed out on mine because I've already done it, but please make sure you install this DNS SD. This is going to make things appear to your system that wouldn't have appeared if this wasn't installed, and it will be making your life so much easier. Okay, so this is what we need to install. I don't do anything with Arnie. Maybe install it anyways. Probably couldn't hurt. But I'm not going to press install because I've already installed this stuff. So we're going to press cancel. But all of these installers go pretty quickly, and having everything that we've talked about installed here will help you greatly. So install them and then come back to the video. Okay, so you're back to the video here, and we are progressing through things. You've got all of your software installed, and you've got all of your hardware connected. This is awesome. The first thing that we're going to do is we're going to connect to the intercom. And I'm going to do that with AZEdit. I'm going to press my Windows key and start typing AZEdit. And I'm going to use this 5.50 because I know that it is what was listed for the Odin. And it's asking me to select users. Man, this is going to be where it doesn't look like I did a really good job of defaulting. But I bet if it asks, there's an admin for you. If not, we're going to connect like to the username admin. Admin is the default user or super user maybe for RTS gear. I would advise that you don't delete it. Okay, it's unable to connect to an intercom. We're entering file mode. Okay, this is expected. And look down here in the status lights, there is no talkie-talkie. All right, so we're going to go up here to options, and we're going to go to communication. And we're going to, regardless of what your selection box here is, we're going to put it on network, and we're going to use the ... Oh, look at that. Odin is here ready to be selected. It has been given an IP address, and we're going to press OK. And we're going to press connect. Look, 2 green balls means talkie-talkie. And we are ready to actually connect to this intercom. It may not give you a login, but mine is. And so the password for admin is PASSWORD. And we are connected to our intercom. I've got alarms. I'm not going to go look at them right now. We are connected to this intercom. This is great. But we have I'm not sure what the next portion is going to look like in a default install, so I'm going to just jump right into it. The first thing we need to do is tell the intercom how to look for ports. The ODIN can connect via RVON, Legacy, OMNEO, or 2-wire. And we need to basically lay out the ports in this intercom and how to connect to them. So it's here in the port allocation table. Like I said, I don't know what your default will look like. I've tried my best to default this one. So let's look at it. Okay, as I mentioned earlier, this intercom is 112 ports licensed. And it is has 16 physical ports on the back, and then the rest are going to be IP connections. So in order to make this a nice, simple install, I'm going to not jump around in this whole port allocation table. I'm just going to assign the ports exactly as we need them for our project today. First one is the producer. It's going to be connected via analog. The second one is the director. It will be connected via RVON. The third one is technical director, is going to be connected via OMNEO. And then we're just going to use program, because it's the way it is in this table and the way I introduced them. We're going to put that into port 4. That will be a Dante connection, which will be an input to the frame. And then we're going to have this Dante Beltpack, which will be a Dante connection. And then we will have the last port, which is going to be a KP, which will be an OMNEO connection. Okay, so back here in the port allocation table, we're going to make our ports match what we just saw in that chart. So the first one, it's been default named N001, is going to be an analog input-output port, and it'll be channel 1. And then the next one we decided was going to be RVON, and RVON is one of the connection styles here. We have OMNEO and 2-wire. We're not going to get into 2-wire. It's just, we're not even going to worry about it. The third portion is going to be an OMNEO connection. Okay? And then that's the technical director's Beltpack, our KP panel. And then we're going to have a Dante connection for audio. Let's look for Dante. Okay, wait. There is no Dante connection. All right, this is the first kind of understood thing that isn't maybe explicitly outlined. When we say Dante, RTS says OMNEO. So we're going to choose OMNEO, and we'll talk about why that is an OMNEO connection, but it's actually made in Dante later. So our program input will be OMNEO, and then our OMNEO Dante Beltpack will also be an OMNEO connection. And then for the Beltpack, we're also going to choose OMNEO, and that will truly be an OMNEO connection. Okay, we've got some zhuzhing here to look at the channels. We can make this RVON 1. But here's where some of the pre-configuration that is popping up in this intercom is going to get us. So I'm going to choose channel. I've already used RVON channel 1, so I'm going to go down here and kind of muddy the waters a little bit. I have the RVON connections pre-configured in this intercom way down here in ports 101 and such. So I'm just going to go remove this zhuzhing, and now we don't have any errors, and we can all just forget that happened. So RVON channel 1 is going to be our directors panel. OMNEO channel 3 is going to be our TD's panel, and then 4 will be program, 5 will be the Beltpack, and then 6 will be our wireless Beltpack. So let's just go over back to our sheets here and make some notes on this so that we don't have to worry about it later and it doesn't trip us up. So we could go back into that port allocation table and make those a little bit more normal starting at OMNEO 1. But it kind of doesn't matter. We're not always going to be able to maintain perfect systems. So I think this is a little bit better choice that we just make notes of where this is going to be connected, and then we connect it according to our notes. All right, so we're going to come back to this port allocation table, and we're going to apply. And do we want to send this port allocation to the intercom? Sure, sweet. Ta-da, it's been done. Okay, so now let's jump forward a little bit and see what we can see about panels that are already connected. Do we have any panels that should be connected at this point? Actually, we do. Our first panel, that legacy panel, is connected. Look, there it is. Its COM status is OK, and it's reporting as a KP7. I don't know why it says KP7 instead of KP12. It doesn't matter to me. They've got model numbers that they don't need to explain to me, and that's fine. We don't have the other panel, so there's nothing else connected. So we've got some more work to do. I want to name these ports so that we can keep seeing them as things that make sense, because I deal better with names than stupid little serialized numbers. So I've clicked the Alphas tab, and I'm going to name this. We're going to name this Producer, and then we're going to click Next, Director, TD, Program, it's BP1, and then WBP1, and we're good, right? Is that what we've specified? All right, so we have Producer, Director, TD, Program, BP1, and WBP1. So let's send those changes here. And as far as the intercom looks like, those names are established. Okay. So we've talked about the port allocation table, and now, and we have our producer panel, which is connected. Let's go connect some IP panels. Okay, so we're now ready to connect some IP panels. I'm going to press my Windows key. I'm going to start typing IPEdit. Up pops the program IPEdit. We're going to click it, and up comes what looks like a completely blank, useless chart or table. When you connect your program for the first time, it's probably going to ask you, what interface do you want to use to do the searching? I'm going to make that choice appear here in Discovery. You're going to need to choose the wired network device that is connected to the network with your other devices. I know that mine is the Realtek PCIe blah blah blah, and it's the wired networking jack that is connected to the same subnet as all of my other devices. Now, because we installed all of the components that it asked us to, when we press this plus button, it's going to go to Add Devices and look at all of the things that are going to show up here. Wow. This is going splendidly. I'm going to connect to, or I'm going to choose this one. I'm going to hold Shift, and I'm going to choose this one, and it's going to allow me to add all of these all of these devices at once. Let's add these suckers. This is the catalog of devices. We have an Odin. We have an Odin. Why do I have two Odins? Ooh, that's a good question. The program IPEdit is used to configure R or RVON devices, as well as NOR or OMNEO devices. And depending on how you sort this view, it might show them to you as RVON separated from OMNEO. We clicked on the device and it is not, we are not connected to that device. Look at that red X. We're going to go over here and we're going to log in with that magic admin tab password. ODIN frame page here for the RVON section, and here is an RVON KP. These are the two devices that we're going to point at each other. So one little thing about RVON is that your static IP your address must be static, and there's not quite the discovery tools that there are in OMNEO. I'll show you what I mean. But we're here on the ODIN frame. We've specified that channel 1 of the RVON is going to be this KP. And you can actually see that in the ODIN frame, it's already pointing to the director that we programmed in the alphas. That's pretty cool. So let's go ahead and put the IP address of the KP that we want to use. And that IP address can be seen right here. So we're going to type in 10, 11, 12, 161. And so now we've specified where, this is how I would think of it if I was you. We are going to specify where this port is going to look for a connection. This port is going to be connected to this KP. So we've done half of the battle. Now we need to go to this KP and specify where this port looks for a connection, because the way you should think about it is that you have to instruct the port or the device on where to get its connection. So this IP address here is going to be the ODIN frame. So 10, 11, 12, 54. Does that make sense? Now this is going to be channel 1, and this is going to be channel 1. And let's go ahead and send that change. And you can see here that this, ooh, look, it's connected. The green box on both sides is connected. And in this, we have a connection. Now, let's go back over to AZEdit and see if we can see that change register in AZEdit. Look at that. Just like that, the directors panel has been connected. And so we've now connected a legacy panel and a RVON panel. This is going splendidly. Now let's go over to the ODIN frame and start to connect an OMNEO device. As we talked about earlier, this channel 3 is going to be where we connect the TDs panel. So let's click around here and look for point of ellipses. Look, this is where our discovery tool comes into play, and we can click for these choices. We're going to choose this KP4016. It autofills the IP address. Let's go to that KP and make the same selection here. Destination, ellipses, ODIN frame. All right. Let's see, is this right? Channel 17? No, I don't think we're going to be using channel 17. I think it's channel 3, right? We specify these things and we press send changes. And look, it knows that it's supposed to be connected to an OMNEO device. It currently isn't. Maybe we give it a couple seconds and see if it connects. We can go look at it from the ODIN frame perspective. Yep, this has been done right. It's channel 1. Let's just give it a little bit more time and see if this connects, because it should. I do know that sometimes these devices reboot and your green check mark right here will turn into an X and then it will come back. All right, and the panels have linked up. In our third port here, we have a green set of bars. Let's go back over to AZEdit and check on the status of our key panel. Look at that, our third key panel is connected. This is going swimmingly. Now, we're going to address this idea of program audio. This is where we're going to start using for the first time Dante controller. Let's go figure out about Dante controller. Dante controller is a free download from the company that makes the software and hardware for every single device that uses their technology. We can just Google for Audinate or a Dante controller. It's a free download after you register. And I have already have it installed, and so let's go look at it. Let's see. This is the view that comes up when you open Dante controller. Now we can see a bunch of devices here with names. These names have been crafted a little bit already because these are devices that come out of my working inventory, but I've tried to sanitize them so that they're not a distraction. I can tell you that right here in the transmitters, we have a AVIO analog input 1, and it is capable of making one channel of Dante. And here on the listener side, we have an ODIN frame. And out of just simplicity and convenience, it's going to have 112 receivers down here. And here in channel 3, something has been patched in Dante controller, or appearing to be patched in Dante controller. This is the key panel that we have already patched in IPEdit. And it doesn't... Dante controller is displaying that another program has made this patch. We're not going to be using that patch. We're going to be throwing another patch. Here in port 4, we're going to put audio from this AVIO input device. We attempt to make the patch, and look, there it is. Now, port 4 has been fed by this program device that's receiving program audio. Now, we just made a patch in Dante controller. I wonder if the IPEdit knows that this patch is there. Let's go back to IPEdit. Look at this. Here in IPEdit, we can see that something, a half square, is showing that there is a connection on port 4. How about that? So we can learn stuff in IPEdit that we did about stuff that we did in Dante controller. Let's go over to AZEdit and see if AZEdit knows that that thing is there. No, it does not. There is no indication in AZEdit that there is anything connected to port number 4, and this is correct. AZEdit is in charge of the audio logic, and it really wishes it could benefit from knowing that there's a KP connected, but it can't tell whether there is any kind of audio only connection. So this is as much information, which is zero information. This is as much information as we're going to get about this port. So the next thing in our task list, let's go back to the task list, is to connect this Dante Beltpack. This Dante Beltpack is going to be connected in Dante controller. So let's go to Dante controller again. And here we have a BP Beltpack model 372, and that is the Beltpack that we are trying to connect. So what we're going to do is we're going to make the talk portion of this talk on port 5. We're going to throw that patch right there. And then we're going to make the BP 372 channel 1 be fed by the intercom frame itself. And so we'll open up Odin frame here, and channel 1, was that port 5 that we were going to do that on? I believe it was. So then we're going to throw the patch there, and this channel 1 of this Beltpack has been patched to port number 5, just like our table of tasks shows us. Again, in AZEdit, we will get no information about this Beltpack, but in IPEdit, we will see a green square, and audio has been connected. How about that? It's pretty cool that this IPEdit can tell us about stuff that has been done in Dante. Pretty cool. All right, the last task that we have on our epic journey here is to connect this ROAMEO access point to the frame, and then we're going to connect Beltpacks to the access point. Okay, we may not do them in that order, but we'll talk about things here real quick. One thing that is important for, I'll say this, and maybe it might turn out in your system that it's going to be important all the time, is to note this domain. This domain needs to be blank, and you may have to start to use static IP settings in order to make this local be local domain be available or specifiable. So it's this address was specified by the DHCP, and this is the address that we're going to use, and that's going to be fine. So let's go through and look at the way we do this. We're going to go to the point of ellipses right here, and we're going to choose this Odin frame, and we're going to add it, and it's not going to be channel 14. I believe it's going to be channel 6. And then we're going to go down here, and we're going to copy. It's a bit of a MAC address. It's found on the front display of the Beltpack, and it's going to be 0009246B50 for my exact Beltpack. Yours will be different. And we are going to make sure that the decked, you note this right here, this will be involved in adopting the Beltpack, and this is settable. We're going to use zone 1, and we're going to use this audio codec. And here we need a sync master for each zone. So there's only one access point in this zone, and so we're going to use it as the sync master. So this is all right here on the access point. We've specified where it connects to the Odin frame. We've specified the Beltpack that it connects to, and we've specified that it's the sync master. Now let's go back to the Odin frame, channel 6, wireless Beltpack 1, and we're now going to connect this to the ROAMEO access point on its channel 1. So we're going to send these changes. Okay, the access point has rebooted, and we have one green box here. Now, this red box refers to the fact that the Beltpack has not been adopted yet. So we're not going to get that green box without this Beltpack attached. So now we're going to go over to the Beltpack, and we're going to complete the adoption process there. So it works kind of like this. Menu key, and then we're going to go to the gear here, and we're going to press this icon, which means adopt. Yes, I want to adopt. This is the right system ID. Scroll through there. And this is the right pin. And the state is subscribing. So the Beltpack will reboot, and we will see it come back up. And here on the software, we're going to see that it starts to adopt. There's a green dot there, and then there is the connected portion there. And let's go back to the Odin frame. Look at that. We've got another green over green. Now, this is the really cool part. Let's go back over to IPEdit and see if there is anything we can learn here. Look at that. Port 6, a wireless Beltpack, is okay and connected.
And just like that, we have started to set up almost every example of how you can connect to an Odin frame. I hope you guys have enjoyed this. It's been fun for me to shoot, but also, I don't know, like I said, this one was just a little difficult. So I hope you've enjoyed it. I would love it if you guys could ask questions and help me know how to help you guys. As always, you guys can reach out to me with questions. If it's a question for everybody, do it here on the YouTube channel. If it's a question about your exact setup, call me. My phone number is everywhere. Maybe even I put it in a graphic right here. Hey, look, there it is. So I do invite you to reach out, and hopefully this has been helpful. And let me know how I can help. And subscribe, like, all that stuff. Almost 500 subscribers. I can't believe how many comm nerds there are out there. Maybe we'll get some more. All right. See you guys soon.